And we're back, and today we're going to talk about squares. Now, a square is just another parallelogram because it has two pairs of parallel sides. So square's parallelogram follows all the parallelogram properties, but most of you already know about a square is that all the sides are congruent and all the angles are congruent. So if I go take a look at quadrilaterals, a quadrilateral is really just any shape with four sides. And we've looking, like that's a quadrilateral, that has four sides. But what we've been looking at is very specific quadrilaterals, such as a parallelogram or a rhombus, a rectangle, and now we're going to get into square. Now, if a rhombus is a parallelogram and a rectangle is a parallelogram, well then a square is also a parallelogram because a square is going to pull the rhombus properties and the rectangle properties. Remember that our key feature of a rhombus is that all sides are congruent, and a square has all sides congruent. So I can go ahead and put ticks all the way around. That's something that you probably already knew about a square. But a square also pulls from rectangle properties, and a rectangle has all angles congruent. So think like rhombus, sides congruent, angles congruent. And a square follows both of those properties. It has all the sides congruent and it has all of its angles congruent. Which means that, I had to sneeze there for a second, that the square is going to take all of the rules from a rectangle and a rhombus and a parallelogram. So a square is pretty much all of our rules in one. So if we take a look at some of those rules, like the rhombus, all the sides are the same. So if one side's 7, then all of our sides would be 7. Okay, and then also like the rhombus, my diagonals would be perpendicular. So if I drew these in here, my diagonals would be perpendicular. Put 90 in there. Okay, well from the rectangle, I know that all these corner angles are 90 because that's what it was in a rectangle. And then from the rectangle, I also know that it's symmetrical this way and all of my diagonals are the same. So I know that all of these sides are exactly the same. I could put ticks on there. And then from the rhombus, I know that my angles are cut in half. So from the rectangle, I knew that they were 90. From the rhombus, I know that they're now cut in half. And so a lot of this stuff you probably already knew about a square, but now we're just remembering that we're pulling it from the previous shapes. So the key feature of a square is all sides congruent, all angles congruent. And then whenever we cut those angles in half, well, half of 90 would be 45. And then what I've created now is I have all of these right triangles. So like I have a right triangle here, and I have a 45, 45, 90 triangle. And then I have these right triangles in here as well, and these are all 45, 45, 90. So if it's a square and I asked you to find the diagonal, well, it's just a 45, 45, 90. You could set up your little chart for 45, 45, 90. So remember that our 45, 45, 90 chart had 1 and root 2 on the bottom. And if I'm looking at this triangle right here, well, the legs are the ones with the tick, so that would be 7. If I'm trying to find the diagonal, that would be x. And then whenever I cross and multiply, so x times 1 is x, 7 times root 2 is 7 root 2. Well, then now I know that this diagonal is 7 root 2. Well, that would make that diagonal 7 root 2. And then like the rectangle, all these pieces are the same. So then if I split it in half, then I would have each piece would be 3.5 root 2 because I would just take the 7 and split it in half. So people tend to like squares because the key trick with a square is just remember rectangle rhombus rules. And for the most part, the square is 90. And then if you cut 90 in half, you get 45, 45. And then you can remember your 45, 45, 90 chart. So let's take a look at some specific examples with squares. And don't forget that you can write all of this down to use on your formula chart that you can utilize this unit. Okay, so taking a look at some squares specifically, I need to remember that my diagonals are perpendicular. That's where they're 90 in the middle. Okay, I can also remember that my diagonals are congruent. So that's why there's all the same. And that the diagonals bisect the angles. And that if all the four corner angles are 90 degrees and then I cut them in half, that's how I get all of these 45s in there. So let's take a look. If the measure of angle AED is 5x plus 5, find x. Well, if we're looking at squares today, I just need to remember, what do I know about all the angles in a square? And that's that all my middle angles are all 90 degrees. You can just do one box if you want. All my corners are 90 degrees. And then when I cut those corners in half, that's how I get the 45. So if I'm talking about angle AED, well, that's in the middle with the diagonals crossed, that's 90. So how am I going to solve for x? Well, 5x plus 5 would equal 90 degrees. And now I'm going to solve for x. So subtract 5. So 5x would equal 85. And then divide both sides by 5, x would equal 17, and that's it. What's nice about the squares that's a little bit different from the rhombus is that in the rhombus, my corner angles were cut in half, but they could be different numbers. Like this one was 135 and 45. That one I made up, it was like 70, 70, 20, 20. That's 67, 113. But in a square, there's not really that option. It's either going to equal 90 or it's going to equal 45, and then that's it. Those are my rules. So taking a look at this next one, if I'm talking about angle BAC, okay, well, it's a square. I need to look at angle BAC, and if I know it's a square, it's either going to, my angle's going to equal 90 or my angle's going to equal 45. So if I look at BAC and I notice that it's half of it, so then BAC right there would equal 45. So if 5x equals 45, and then I divide both sides by 5, then x would just equal 9, and that's it. And then if I take a look at this one, now I'm talking about sides. So it tells me that MH is 8. Okay, well, if MH is 8, then I know all my sides are 8, and then it wants the length of AH right here. Okay, so if I sketch this out, and I remember that my corners are 90, well, then I know that I have a right triangle here. Now, what some people would do is if I redrew this picture over here, essentially what I have is this. I essentially have a right triangle. I know that side's 8, and I know that side's 8, and I'm trying to find the hypotenuse. So you could do Pythagorean theorem if you wanted. You could do 8 squared plus 8 squared equals c squared and go from there. But if you remember, what's special about a square is that these angles in here are 45 degrees. So instead of Pythagorean theorem, I could use my chart. So if I use my chart for a 45, 45, 90, remember 45, 45, 90 has 1 and root 2 at the bottom. And then if I'm looking at this triangle right here, ask yourself, what are the legs? What piece would go with the 1? And that's 8. And I'm trying to find AH, which is the diagonal, so there's my x. Now I'm just going to cross multiply. X times 1 would be x equals 8 times root 2 would be 8 root 2, and then that's it. So AH equals 8 root 2. Now, if I know that this whole diagonal is 8 root 2, well, then I know that this other diagonal is 8 root 2. And if I asked you to find each piece, well, just ask yourself, what's half of 8 root 2? And that would be 4 root 2. That's it. Okay, and then for this one, it tells me that MS is 3. And then I know that AS is 3. And then it wants the perimeter of the square. Okay, I know that this piece is 3, so that piece is 3, which would make this whole thing 6. What I need to do is I need to find this piece right here. So I can do it a few ways. I can pretend that this is 6 and then try to work backwards to get that. But if I also remember that I have 90 in the middle, and then those corners are 45 and 45, a square pretty much divides into just multiple 45, 45, 90s. So like back over here, that was a 45, 45, 90, but then also this is a 45, 45, 90. And that's just because in a square, so many of our parts are the same. So if I go back over here, I'm trying to find the perimeter, but to get the perimeter, that means I need one of the outside parts. And then once I have it, I can figure everything else out from there. So let's call this x. I could do a squared plus b squared equals c squared if I wanted to, but I'm a bigger fan of our chart for 45, 45, 90, so I'm going to use that. So what goes at the bottom of the 45, 45, 90 chart would be 1 and root 2. And then I have to remember that 1 goes with the leg, which would be 3. And then root 2 is the hypotenuse, so that would be our x. And now I'm going to cross multiply. So x times 1 would be x equals 3 times root 2 would be 3 root 2. Okay, now I'm not done with the problem. That just means that if one side's 3 root 2, then all of our sides are 3 root 2. So if we wanted the perimeter, I would have to do 3 root 2 plus 3 root 2 plus 3 root 2 plus 3 root 2. Ask yourself, what's 3 times? There's 4. So 3 times 4 would make our perimeter 12 root 2. And that's it. Now, this unit can get kind of tiring with so many shapes and so many rules. So we just finished looking at parallelograms, and then we're going to take a look farther on at kites, trapezoid, isosceles trapezoid. But don't forget that you have this little formula chart here. And we could think of our quadrilaterals as breaking up into some different categories. And that's really 3 categories. So quads can break down into 3 parts. That's if nothing is parallel, and that would be a kite, which is what we'll get into next week. If they have one set parallel, and that would be a trapezoid, which is also what we're going to get into later on. Okay, within trapezoids, we're going to talk about isosceles trapezoids. So a kite's with nothing parallel. A trapezoid is with one set parallel. And then what we've spent this past few time on these past few videos have been all about parallelograms, which have 2 sets parallel, like both opposite sides are parallel. And then with parallelograms, we've talked about rhombuses, where the sides were congruent. Then we talked about rectangles, where the angles were congruent. And then a square pulls properties from both because it has sides and angles congruent. So just kind of use this chart. If you get stuck, just remember, try to organize your thoughts and then use this formula chart to help you out. Good luck with your practice.